like a Hellcat.
Hi guys, so welcome back sa ating YouTube channel. So in this video, pag-uusapan naman natin yung ating last group, o that is the factor group. So before that, balik tayo dito, no. So ano ba yung N over G o yung tinutukoy natin dito? Since sinabi natin yung H, again, so H is a subgroup, N is a subgroup of group G, tapos N over G siya. So masabi natin ano yung N over G? N over G is a set. Okay, kasi if and only if the product. So pag sinunod natin dito yung H, okay, so this is H over G. This is just equal sa, pag nangyari, rho 0H, rho 1H, sigma 1H, and sigma 1H. So, yan isusulat. Or, gusto mo yung right coset, this is H over G. This is just equal sa H rho 0, H rho 1, H mu 1, and lastly, H mu 2. Okay? So, ayan yung inilalagay o yung ginagawa ng theorem na yan. So, now, proceed tayo dito, no? So, after studying normal subgroup, we now discuss one application of these normal subgroups and the construction of factor group. So, napaka-importante kasi nung ginagawa natin dito at the same time neto. Okay? Now, let's have a definition. So, let H be a normal subgroup of a group G. So, again, normal subgroup na siya agad na. So, since normal subgroup na siya, skip na natin yung part na kailangan equal yung left and right coset. Hindi na agad-agad. So, since normal siya, kahit kunin mo na yung left coset, okay na yun eh. Tandaan, kunin mo na, pag sinabi ng normal siya, or pag nagbigay ng example dito, pinakita na construct the factor group. Okay, so, ibig sabihin, hindi mo na kailangan kunin yung right coset. Hindi mo na kailangan pakita yung na equal yung left and right coset. Kasi nga, alam natin siya ay normal. This is the definition pa lang. Okay, so, and let G over H be the set of all distinct left or right coset. So, yun nga yung sinasabi ng theorem. Okay, so G over H. Dito kasi is N over G, no? Kung napansin mo, sir, N over G, tapos dito G over H. Ay nga, dito nga siya nagbago, actually. So, bigla siyang binago pagdating dito sa definition. Kumbaga, pinakita lang dito na, this theorem states that N over G, ito yung set niya, nalaman niya. Ngayon, in this group, ang kanya application naman is G over H. Yung G over H naman yung gagamitin. So, hoping na wag ka malito. Again, this is just theorem, pre-introduction. Hindi natin siya totally gagamitin. Tandaan. Okay, and at the same time, iba yung process dito. Kasi ang process dito is yung product ng dalawang set. So, dito, iba yung gagawin. Okay, so, again, proceed tayo, no? Let G over H be the set of all distinct left or right cosets of H in G. And we can define the multiplication in G over H as follow. Okay, so we have AHBH is just equal sa ABH. So, itong ano, napakadali. Instead na gamitin natin yung isa-isa minumultiply or isa-isa ina-asterisk, ano ginagawa? Kung gusto mo kunin yung AH times BH, kunin mo lang yung A times B. Okay, yung mismong A times B lang, kunin mo, tapos saka mo i-multiply sa H. Napakadali. Okay, so in addition, so kunyari, this is normal multiplication or asterisk. So again, ang gagawin mo lang, kung meron ka AH, BH, ang gawin mo lang, A asterisk B times H. So kunin mo yung A asterisk B, saka mo siya kunin doon, saka mo i-construct a coset doon sa loob. Okay, then we have A plus H plus B plus H is just equal sa, alam mo na plus yan. Okay, so again, yung asterisk dyan sa gitna is plus. So, A plus H, B plus H, just is simply A plus B plus H. Okay, this is also H plus A, HB, that's H plus AB. So, dito, HA, HB, this is equal sa HAB. Okay, so napakadali. Add mo muna yung AB or asterisk mo yung AB before mo i-left or i-right coset dun sa ating example. Okay, so napakadali nito. Let's try to construct yung ating multiplication group or the factor group. Okay, so ito kasi yung tinatawag na multiplication group. Hoping na medyo mabilis. Okay, so construct the multiplication table for the right cosets of H in G where number 1, let G be equal to Z comma plus and H is equal to 3Z. So since right coset ang pinag-uusapan, alam mo naman na yung mga right coset neto. Okay, so we have the right coset neto. So the right cosets are, ano ba yung right coset neto? 3Z plus 1, plus 0 rather. We have 3Z plus 1 and we have 3Z plus 2. Okay, so we need to construct the multiplication table nito. Okay, so we conduct this the asterisk. So dito yung asterisk natin. Okay, so susulat natin dito yung mga group. So sulat natin yung una si 0 plus 3Z. Sunod 1 plus 3z. Lastly, 2 plus 3z. Okay, next we have 0 plus 3z. Okay, then dito sa kabila 1 plus 3z. Then lastly we have 2 plus 3z. Okay, so gagawin lang natin yung idea nung sinasabi kanina. So ang idea lang is something na since addition to, i-add mo lang yung mga number before mong i-plus dun sa coset. Okay, so since meron naman tayong result na nito, so yes, gamitin na lang natin. Okay, so una we have 0 plus 3z. So lagay natin din yung mga solution, no? So una we have 0 plus 3z plus 0 plus 3z. So obviously this is just simply 0 plus 3z pa rin. So this is just 0 plus 3z. And again, this is a multiplication table. Okay, so since multiplication table, alam natin na sa group multiplication table dapat walang naulit sa right, sa column, then sa row. Okay, so for every row, for every column mo lang naulit. Then at the same time, obviously parang sa atin dito ay lumalabas na identity element yung 0 plus 3z. Okay, kasi siya yung subgroup mismo. Okay, so 0 plus 3z plus 1 plus 3z, this is just 1 plus 3z. Sorry, left coset yung nagawa ko. Right coset pala yung pinapagawa. Okay, so dito left consider ko dito left coset. Although binagay ko, ito ginamit ko 0 plus 3z. Oh my. Napakalupit ko talaga, sir. Napakalupit mo. Kanina pa ako nag-error. So, I think understandable naman ano yung pagkakamali na sir na ginawa. Okay, so again, kinonstruct ko yung multiplication table for the left coset of H and G. So, dito. So, ito yung ginagamit ko. Okay, so we have, this is 1 plus 3z. So, we have 2 plus 3z. So, this is 2 plus 3z. Obviously, 1 plus 3z. 1 plus 3z plus 1 plus 3z. This is just 2 plus 3z. Okay, then 2 plus 1 plus 3z. 1 plus 2. This is just 0 plus 3z. Sir, bakit naging 0? 1 plus 2 is 3. So, we all know that 3 plus 3z is equal sa 0 plus 3z. Okay, also dito is 2 plus 3z. Okay, next dito is 2 plus 3z. This is just 0 plus 3z. Next dito, this is just 2 plus 2 modulo 3 o modulo 3, that is simply 1. So, we all know that yung 1 plus 3z is equal sa 4 plus 3z. Sa 7 plus 3z. Okay, so this is just 1 plus 3z. Okay, so again, this is the left multiplication table. So also kung ilalagay mo yung right, no, so kung right, baliktarin mo na lang, paki-adjust na lang kung gusto mo isulat din yung right, kasi right naman talaga yung pinapakuha sa atin. So pasensya, hindi ko siya nalagay agad-agad. Okay, okay, so per number 2, no, kunin na natin to para at least din ako mahirapan. So we have G is equal to S3 and H is equal to row 0, row 1, and row 2. So, construct natin yung right coset. So, sulat ko na yung right coset. Sana di na ako malito. So, the right coset of H and G are H row 0 and we have H mu 1. So, obviously, construct lang natin yung multiplication table niya. Okay, so hoping di ako magkamali. So, this is just H row 0, we have H mu 1, and also meron din tayo ditong H row 0 and H mu 1. H row 0, that is H row 0. Obviously identity element siya dito. This is H mu 1, this is H mu 1, and H mu 1, H mu 1. So obviously mu 1 asterisk mu 1. So pag kinumpit natin siya, no, H mu 1 asterisk H mu 1. So by definition ng coset, this is H mu 1 mu 1. And we all know that mu 1 square is identity element or the row 0. Okay, so this is just row 0. So H row 0. Okay, so obviously multiplication table siya or group table. So kung napapansin mo, ano ginagawa nito? Ang ginagawa nito, ng idea na to, ng definition na to, is just yung kanyang left and right coset, meron siyang nako-construct na parang factor group or parang tinatawag na factor group na kung saan may property siya ng pagiging group. So parang anong nangyari, lumalabas na yung H natin o yung mismong H plus yung identity is yung ating lumalabas na identity element dito, tapos yung ibang element. So napansin mo, close siya, associative siya, may identity siya which is 0 plus 3z. Meron din inverse yan. So we all know that the inverse of 2 plus 3z is yung 1 plus 3z and vice versa. Okay, so actually napaka importante ito. Okay, so now let G, so we have theorem 7.3.1, no? So let G be a group and let H be a normal subgroup of G. The set G over H is equal to HA such that A is an element of G. Again, that is HA. So, multiply ko lang the HA. So, right coset pala yung laging ginagamit dito. Okay, so is a group under multiplication of coset. So, I don't know ano yung inaano na itong discussion na to. So, I'm checking din ano ba yung gusto niyang gawin. Okay, so check ko lang. So, ayun, hindi naman kailangan. So, hindi ko naman siya kailangan ipakita or prove. Kasi obviously importante is the next definition. Again, this is just a theorem 7.3.1. So let G be a group and let H be a normal subgroup of G. Then the set G over H is equal to HA such that H element of G is a group under multiplication of coset. So napansin mo naman, group siya under multiplication of coset. Why? Andyan yung identity. Okay, so again, the identity element is yung H. Okay, may inverse siya, associative siya, tapos at the same time, tapos multiplication of cosets. So, note that yung asterisk na yan is the multiplication of cosets or asterisk of cosets. Tandaan yung bagay na yan. Okay, so sorry, naglagay pa ako ng space, di naman pala kailangan i-prove. Okay, so next is definition. So, if H is a normal subgroup of G, then the group G over H discussed in the preceding theorem is called the factor group or the quotient group of G by H. Okay, so ibig sabihin, anong basa natin sa G over H? This is the factor group or the quotient group of G by H. Okay, so that's G by H. So meaning, ano to? So ano yung ating, so since nabuo natin siya, ano yung masasabi natin dito? This is Z. So G over H, no? This is the factor group over, or the factor group of Z by 3Z. Okay, so this is the set containing 0 plus 3Z, 1 plus 3z. Ayun, nagkamali na naman ako. Then 2 plus 3z. Although pasok naman sa pagiging let. Okay, so dapat ito daw. So this is 3z plus 0, 3z plus 1, then 3z plus 2. Okay, then comma, asterisk. Okay, so that's yung group dyan. So next, dito naman is S sub 3 by H. This is just equal sa the set containing H, rho 0, H, mu 1, comma, asterisk. Okay, so this is a quotient group. So this is the quotient group or the factor group of S sub 3 by H. Okay, so ganun yung ating basa sa kanya. Okay, so proceed tayo. Yun, medyo mabilis yung discussion natin dito. Buti na lang. So medyo natagal lang kasi talaga ako totally dun sa ating ibang discussion kasi nga mahirap i-explain or para maintindihan mo yung mga susunod na theorem or ibang concepts or definition. Kailangan mo talaga maintindihan yung mga illustrations or example. Okay, so I think naman napaka-useful nun kaya tumagal. Sir, ba't ang tagal? Kasi nga importante na malaman mo or makita mo kung paano ginagawa. So yung iba nga binabasa lang eh. Alam nyo naman yun. So at least may ginagawa si sir. Okay, so number 1, we have example, no? So let G be equal to D4 and H is equal to rho 0, rho 2. So ano ba gagawin natin dito sa example na to? By the way. Okay, so the hidden group rho 0. Construct the group table of G over H. So di ko nalagay. So again, construct the group table of G over H. So yun. Ano ba yung element na ito kanina? Actually, ito yung 4. Kakalala ko ito yung 4. So, hirap lang talaga hanapin kasi sa dami na ng papel na ginawa ko. Okay, so yung right coset. So again, right coset ang ginagamit. Pero again, possible din naman yung ating left coset. So, before mo i-construct o before mo i-conclude na siya ay factor group or quotient group, construct mo muna yung multiplication table. I-check mo kung walang naulit sa row, walang naulit sa column, may identity element, may inverse, okay, then associative. So, actually lahat naman yun is na-verify through doon. So, we have yung right coset nito. So, kopyahin ko lang dito, no? So, this is H rho 0. So, H rho 0 or H. Pwede gamitin actually H kasi wala naman nangyari dyan. Next is H rho 1, H mu 1, and H sigma 1. So again, pwede kong gamitin si H. Although, mas useful kasi talaga gamitin to. So we have the multiplication of cosets. Okay, so rewrite lang natin dito, no? So we have H rho 0, H rho 1, H mu 1, and then lastly, H sigma 1. Okay, next, this is H rho 0, H rho 1, H mu 1, H sigma 1. Okay, so let us multiply. So H rho 0, asterisk H rho 0. This is just rho 0, asterisk rho 0, that is rho 0. So this is H rho 0. Okay, obviously this is H rho 1, obviously H mu 1, and H sigma 1. Dito sa baba, this is just H rho 1, H mu 1, and H sigma 1. Next is rho 1 asterisk rho 1. So ito yung medyo problema, no? So rho 1 asterisk rho 1. So pag napansin mo, H rho 1 asterisk H rho 1, ano lalabas dyan? That is H rho 2. Pero ano yung H rho 2, by the way? Sabi dito, ang H rho 2, o yung H rho 2 rather, yung H rho 2 is equal lang din kay H rho 0. Okay, so baka kasi magtaka, sir, H rho 1, that is H rho 2. Pero si H rho 2, alam natin na siya si H rho 1. Okay, so this is just H rho 0 rather, H rho 0. So huwag ka malilito about doon. And next is rho 1 mu 1. So paano yung rho 1 mu 1 na yan, no? So rho 1 mu 1, ano yung magiging sagot sa rho 1 mu 1 na yan? Rho 1 mu 1 Rho 1 mu 1. So we have rho 1 mu 1. That is rho 2. Okay, so ano yung rho 2? So rho 2 is rho 1. So H rho 1. Then obviously this is H mu 1. So kahit check natin, rho 1 asterisk sigma 1 o rho 1 asterisk sigma 1, that is mu 1. Okay, so tama tayo dyan. So next is dito, mu 1 rho 1. So mu 1 rho 1, check natin mu 1 rho 1. So ano yung mu 1 rho 1? Mu 1 rho 1, that is sigma 1. Okay, so sigma 1 to. So H sigma 1. So dito is mu 1 mu 1, obviously that is identity kasi identity L, so rho 0 to. So this is H rho 0. Okay, next is H mu 1 S sigma 1. So note that the reflection times reflection is rotation. So dapat ang sagot dyan is H rho 1. So mu 1 asterisk sigma 1, that is rho 1. Okay, so check mo rin dyan. Mu 1 asterisk rho 1, that is sigma 1. So kahit lumabas yung sigma 3, okay lang. Kasi nga parehas lang sila nun. This H rho 1. So obviously ito ay H mu 1. Ito ay H rho 1. And lastly ito ay H rho 0. Sir, paano mo nasabing H rho 0? Sigma 1 asterisk sigma 1 is identity element or the rho 0. Okay, so therefore, ano yung ating, so pansin mo may identity element rho 0 tapos inverse siya dyan. Okay, ano yung inverse ng H rho 1? That is H rho 1. Inverse ng H mu 1. H mu 1. Inverse ng H sigma 1 is H sigma 1. Okay, so therefore, the group D4 or the factor group D4 over H is equal to the set containing H rho 0, H rho 1, H mu 1, and H sigma 1. Okay, kama, asterisk. Okay, so yan, ganyan siya. Simple. Next is, to, medyo hirap, medyo pagod na si sir. Dami kong ginagawa, sabi inisip. So, kakayanin naman yan, huwag kayo magalala. May next pa, actually, may next video pa ako sa ibang subject. Okay, so let G be a cyclic group. So, and let N be a subgroup of G. Then we show that the factor group G over N is also cyclic. Okay, so again, if G is a cyclic group and N is a subgroup of G, we show that the factor group G over N is also cyclic. So, paano natin masya-show na siya ay so, paano natin siya masya-show na ganyan? So, pagkakaalala ko, ito yung mga diskarte pwedeng gawin natin, no? Pag ang isang G is cyclic, automatic, yung G is abelian. Tama? So, may theorem tayo na ganun, no? So, every cyclic group is abelian. So, meaning is commutative lahat ng asterisk sa kanya. So, meaning, abelian yung ating group G. Tapos meron siyang group, may subgroup n siya. So since may subgroup n siya, automatically siya ay also abelian. Kasi nga, kung ikaw ay subgroup ng isang abelian group, automatic abelian ka rin. So by element, abelian ka rin. Okay, so yun ang isa sa mga sure natin. Then at the same time, nakalimutan ko banggitin, no? Isa sa mga example, pag yung group abelian, pag alam mo yung group abelian, automatic yung left and right coset are equal. Again, pag alam mo yung group abelian, yung left and right coset equal, at the same time, yung subgroup niya are always, yung lahat ng subgroup niya is always a normal subgroup niya. Okay, so pag yung group is abelian, lahat ng subgroup niya is normal subgroup sa kanya. Okay, tapos yung left and right coset is equal. Actually, it follows na dun sa lahat ng definition. So, sinabi ko na yun. So, ngayon, kailangan natin sabihin dito, no? So, ito yung proof. So, base nga sa sinabi ni Sir, no? So, since G is cyclic, then G is abelian. Okay? Now, since alam natin na every abelian group, so sinabi ko na, no, every abelian group is a normal subgroup. Every subgroup of abelian group rather. So every subgroup, pakilagay ito. Every subgroup of abelian group, so paki-insert yan dyan, of abelian group is normal. Okay? And every cyclic group has a generator. And lastly, and every cyclic group has a generator. Okay, so I think sapat na yung mga sinabi ko na yan. Okay, so again, ito yung magiging laban natin dito. So para mapakita natin na siya ay also cyclic, kailangan natin makapagpakita na siya ay may, kailangan yung G over N na yan is meron din siyang generator. Okay, so now it follows. So lagay ko dito, no, it follows that yung N natin na tinutukoy dito is a normal subgroup of G. Okay, so again since N yung explanation natin, alam natin na every normal, so since N is a subgroup of G, since alam natin G is cyclic, automatic meron siyang normal subgroup. Okay, which is that is N. So N is a normal subgroup of G. So now, mag-let tayo dito. So let tayo dito ng let A element of G, okay, such that the generator or the cyclic subgroup generated by A is equal to G. Okay, so tama naman. Why? Kasi nga, siya ay may generator. So, since si G is cyclic, automatic meron siyang generator. So, by assuming A element of G, so we assume that this is the generator of G. So, let natin dito na, also, let din tayo ng, so, let X element of G. Okay? So, naglet ako ng X element of G. Then, by definition of generator, we have A raised to N is equal to X. So, this is for some N element ng natural number. Okay, so ano ginawa ko? Since ako ay generator, since nag-declare ka na generator A, so kung meron kang nilet na X element of G, alam ko na yung A raised to N, kaya niyang kunin si X. Okay, so yun yung ginagawa ng generator. So kaya ko siya dinefine ng ganyan. Okay, so now, nagawa ko na yan. Ngayon, kukuha na tayo dito sa ating normal, sa ating factor group. So sa factor group, mag-let din tayo, no? Let X N element ng G over N. Anong ating factor group. Okay, so ano ginawa sir? Nag-let ako ng X times N, element ng ating factor group G by N. Okay, so ano masasabi mo kay X N? So we all know, so note that X times N is equal sa A raised to N times N. And also, we all know that yung NN is yung order ng A, element ng A. Naalala nyo na yung order ng element of A na yan, na, so since N siya, pwede ko sabihin na ganito siya. This is just equal lang sa A, N, raised sa N. Okay, this is for some N. Again, this is for some N, element ng positive integers. So ngayon, ano ginawa na sir? Yung a raised to n, nilabas ko yung n sa n. So sir, bakit anong nangyari? Ang ginawa ko lang is something na idea to or something na parang hindi ko yata nabanggit or hindi ko nasabi. Property kasi siya ng ating cost ng factor group o ng quotient group. Isa sa property niya is yung ganitong side. Okay, so again, raise ko lang yung n, equal pa rin naman yan. Ngayon, yung lumalabas na yung a raise sa n, is lumalabas na isang generator. Okay, so, si a raised to n is a generator for or of the quotient group g by n. Okay, so hence, g over n or the factor group g by n is cyclic since meron siyang generator. So this is done. Okay, so sir, paano siya nasabing generator? Kasi a raised to n, so nasabi natin siyang generator, a raised to n is equal to x, napuntahan niya yun. Ngayon, yung a raised to n is something na gawa niya. So, sa xn is napuntahan lang ni a raised to n. Since si a is a generator, napuntahan lang din ni a n. So again, si a generator, so na-inherit niya yung pagiging generator niya kay n. So minultiply ko siya kay n, okay, generator din. Generator ka na rin. Okay, pero generator ka ng isang group na kung saan nanggaling sa amin, which is the quotient group or the factor group g by n. Okay, so yun yung sinasabi ng theorem na yan, or ng example na yan. So next is, we have theorem 7.3.2. So let G be a group and let N be the center of G. Now, if G over N is cyclic, then G is abelian. Actually, napaka-obvious no? If G over N, kung G is a group, tapos meron siyang N is equal to the center of G, so obviously, yung G over N is cyclic, then G is abelian. So, okay, so mapagtatagbi-tagbi naman natin ito actually. So check na natin. So ito yung magiging proof. Okay, so we need to show that for all A and B, AB is equal to BA. So yun yung goal natin. So actually the goal is, our goal is AB is equal to BA. This is for all A and B element of G. Kasi yung G yung sinasabi. So, G is abelian. So, para masabi natin G is abelian, we need to show that AB is equal to BA. But, our assumption is let G be a group and let N be equal to the center of G. So, if G over N is cyclic, so which is nasabi na natin dun sa taas. Okay, now, so natin dito, no, since the factor group of G by N is cyclic. So, gaya na ginawa natin kanina, there exists, so, pwede akong dito, there exists NG element ng G over N. So, ano pansin mo? Sir, kanina sir, ang ginamit ko kasi is ganito, AN. Okay? So, sa AN, that is a left coset. So, which is, sabi ko naman, ang usual na ginagamit natin is right coset sa paggawa ng factor group or quotient group. Pero, hindi ko naman sinasabi na bawal si left coset. Kaya nagamit ko yung left coset doon. Okay? So, dito, ang ginamit ko na para to be specific tayo, since factor group na ginagamit natin is laging right coset, ginamit ko na generator is NG, which is proven naman na natin kanina. So, let NG, so for some NG element ng GN, okay, so for some NG element of GN we have, or such that, there exists NG, there exists NG element of GN such that yung NG raised sa N is equal to NX. So, this is for all X element of G. Okay, so sure ako na may element siya na kayang puntahan. So, that is NX. So, sir, bakit ganun? So, dito kasi, sure ako na may kayang puntahan si A raised to N, which is XN. So, dito naman ginawa ko si NG, kaya na puntahan si NX. Okay, so, for some X element of G. So, now, ang kailangan natin malaman if, ang goal natin, kailangan tayo makakuha ng dalawang element dito. So, maglet tayo dito ulit ng element. So, makailangan natin pakita na AB is equal to BA. So, let tayo na dalawang element, no? So, let NA, then NB, element ng ating G over N, ng ating factor group. Okay? So, again, naglet lang ako ng NA, NB, element ng G over N. Okay? So, since andyan siya, anong masasabi mo kay NA? Alam ko na si NA kaya din puntahan. Si NX kasi kayang puntahan ni NG. Si NG raised to N, kaya niya puntahan si NX. Okay? So, ngayon, ang goal natin is si NA, or so, si NA kaya din puntahan ni NG. Okay? So, kaya siyang puntahan ni NG to be specific, raise lang siya kay R. Okay, so for some R, which is just equal lang naman sa NGR. So this is just for some R element ng natural number or positive integers. Okay, so again, kaya siyang puntahan ni NG kasi generator sa NG. Pero erase ko lang siya kay R. Okay, so hindi natin alam kung ano yung R na yan. Also, we have NB is just equal sa NB raised sa S. So I guess S na lang dito. Which is just equal sa NG raised sa S. So this is for some S element ng natural number. Okay, so now, ano pa pwede natin gawin dito sa mga to? Ang goal natin is something na pakita tayo ng element niya. Ano kayong pwede kong gamitin? Okay, so we have NGR, then NG raised sa S. Okay, so we have NGR and NG raised sa S. So, i-represent lang natin sila actually ulit sa isang letter. So, kung napansin mo, no, yung NGR na yan is element ni factor group. Okay, yung NGR na yan, yung capital NGR, element ni factor group. Pero, gusto ko siyang gawing element lang nung N natin, o normal group natin. So, maglet lang muna ulit ako dito, no. So, let tayo dito ng, assuming ng A, be equal sa N sub 1 G raised to R. Okay, so, N sub 1 G raised to R. So, kasi N yung ginamit ko doon. And B equals sa N sub 2 G raised to S. Okay, so naglet lang ako. Kasi nga AB is equal to BA. Okay, so consider, or now, we have AB is equal to N sub 1 G raised to R, N sub 2 G raised to S. Okay, then, by associativity, this is just equal sa N sub 1 tapos G raised to R N sub 2 tapos GS. Okay? And note na yung N na yan is center of G. Okay? So since center siya na G, ano pwedeng gawin dito? Okay? Since alam natin sa N is center, alam natin na yung G raised to R N2 na yan, yung N is center, element siya ng center, alam natin na nagko-commute siya. So ito ay just equal lang sa N sub 1 N sub 2 G raised to R G raised to R. Again, since si N sub 1 N sub 2 element lang yan ng N natin. Okay, so kasi saan sila galing? Dun sa ating center. Okay, so next is ang goal kasi natin sa mapagtabi ang mga bagay-bagay na yan. So ano pa bang magandang gawin? We have actually commute ulit natin, no? So aso ulit. So this is N sub 1 N sub 2, then we have G raised to R, G raised to S. Tapos pagbalik ta rin, this is just N sub 2, N sub 1. Okay, so since again, sila ay center, so pwede ulit pagbalik ta rin. So this is G raised to R, G raised to S. Okay, then pagpalit associativity ulit, this is just equal sa N sub 2, N1, G raised to R, tapos G raised to S. Okay, so dapat pala yata pinagpalit ko rin tong dalawa. Or something na pinagpalit ko rin. Oo nga, dapat pinagpalit ko rin to. So again, pagpalitin ko rin tong G raised to R, G raised to S na to. Kasi ang goal natin, kailangan mapunta yung NGS dito, N sub 2 GS dito sa kabila. Okay, pero mamaya pa yan kasi huhugutin pa ulit ng N yan. Okay, so again, pag pinagpalit natin, this is just N sub 2 tapos G raised to R, N sub 1 tapos G raised to S. Okay, tapos i-group ko ulit natin, this is N sub 2 G raised to R tapos N sub 1 G raised to S. Tapos pagpalitan ulit natin sila, this is G ko sa N raised to 2. Or pagpalit, i-group ko rin din pala tong dalawang to kasi gusto ko rin pagpalitin sila actually. So ilalapit ko kasi. Okay, so ang goal ko kasi mapagtabi-tabi. So lalapit ko yung G doon. Actually para akong bumabalik sa umpisa eh. Pero pag lalapit ko yung G doon, dito na yung N. Okay, tapos ilalapit ko yung N ulit doon. Ipagpapalit-palitin ko sila. Okay, so again, paano ko siya pagpapalitin? So pag pinagpalit ko to, magiging G raised to S tas N sub 1. So probably andun na yung N sub 1. Okay, so hindi ko na iwan si NGR o si N sa taas actually. So dito kasi nag-start no, N sub 2, N sub 1. Okay, so yun, may napansin na ako, no, yun, ginroup ko. So, okay. So, again, ang idea nito, GRN sub 1, siya ay normal subgroup. Okay, so siya ay center. Okay, so yung G raised to R multiply ko sa N sub 1 which is center, center pa rin siya, pasok siya doon. So, meaning, idea nito, pwede niyang i-move to yung GS sa kabila. So, this is just equal sa N sub 2, tapos nandito si G raised to S, tapos nandito si G raised to R, N sub 1. Okay, then rearrange lang natin, this is N sub 2, G raised to S, tapos arrange natin to, this is N sub 1 G raised to R. Okay, which is this is just equal lang sa B and A. So therefore this is commutative. Okay, so again, yung idea is something na okay, ako ay normal center lang din ako. So ginagawa mo is something, tumikit ka sa akin, center lang tayo, commutative ako, multiply mo, commutative ka pa rin. Okay, so i-move ko lang sa kabila, tapos i-re-associative ko lang, or associative by associativity lang, then makuha ko na yung BA, which is N sub 2 GS, G raised to S, and N sub 1 G raised to R. Okay, so therefore G is abelian. Okay, so that's all in this video. So hoping na natutunan mo si coset, si Lagrange, si factor group, tapos si normal subgroup natin. So again, napaka-importante ng factor group na to, lalo pag isomorphism na tayo. So again, thank you for watching. Hoping na may natutunan ka.